Hello, everybody. ESM loaders. We are not going to talk about ESM. We're going to talk about ESM loaders. I have talked to death about ESM at NodeTLV and other conferences. By the way, those that raised your hand on import, can you please raise again? How many are using TypeScript with import? You're not using import. You're using require and transpiling from import to require. So you should have lowered your hands. I'm sorry, but you are using require. Mostly. TypeScript has added native Node ESM only in version 5, I think, where it transpiles imports to import. So if you're trying all these things I'm going to talk about with ESM loaders, not with TypeScript, or with TypeScript with native ESM. Okay, ESM loaders. First of all, you heard about me, whatever. I feel very uncomfortable about this talk. I just said it to my people there. It is immensely heavy technical stuff. Lots and lots and lots of code. So if you're into the fluff, there's an amazing talk with me, I think, about node test, which is an amazing thing. But if you're into heavy, deep technical stuff, go for it. I try to make it as simple as possible, but there is only so much I can do about ESM loaders to make it as simple as possible, so there we go. Okay, let's get a few things out of the way. First of all, a little bit about what ESM is like for those people that don't know. ESM is the standard JavaScript module system, and then since version 12 or something like that, 14, it is also native to Node.js, so Node.js understands import. There's no need to transpile. CommonJS is the module.exports and the require, and ES modules is the export and import keywords part of the JavaScript standard. Okay. Next thing I want to get out of here, there are a lot of ESM haters in this conference. I will not name names, but they know who they are. So for all you people that think that if CommonJS was good enough for my grandparents, it is good enough for me, I say this: I fart in your general direction. Okay. ESM loaders, enhancing module loading in Node.js. So what is module loading? And this is interesting. Let's talk about module loading because we're saying it so much. What exactly is it? First of all, what is a module? This is a module. It is basically another name for a file in JavaScript. It's a glorified file. We want to call it module. Let's call it module. And what is module loading? So this is a module. What do we do to load it? We run it. So loading a module is basically glorified execution. We just run the module code and we're done. Module importing is when we import. So we're still running the module, it's glorified execution, but there's a little bit of binding between what is exported and what is imported. It's basically the same variable. So it's glorified execution with some binding. So loading is glorified execution with some binding. We are not going to talk about binding here, although I have an interesting talk which talks about the nuances of binding in ESM. Go to YouTube and see it. The phases of module execution, again, I will not delve into it. Same talk at NodeTLV, but basically it's resolving the URL. It's taking what is imported and figuring out where the file is, reading the file without executing it. ESM recursively does 1 and 2 for all the modules in the graph, just analyzes everything, loads, reads the file, and then recursively runs the files in a bottom-up order. I am not going to delve into that. It's an interesting subject until. What are module loaders? Module loaders help us hook into the first 2 phases, resolving the URL and reading the file. And we have module loaders that change how Node.js resolves the URL. And we have module loaders that change how Node.js reads the file. By the way, I'm talking about URLs as if we're doing HTTP. We're mostly doing file because Node.js doesn't do HTTP imports, okay? But ESM says something very simple. all the specifiers, everything in ESM is URLs. So we will be talking about URLs during this talk. Obviously, all the URLs that Node.js deals with are file colon / URLs for the file system. Let's talk about enhancing the resolution phase, where we have a specifier in the import and we need to change it, figure out where the file is in the file system. And please note, we will be receiving a lot of sample code. This is demonstration code, not to be used in production, no error handling and no edge cases, etc., etc., etc. This is for simplicity and not for production. Okay, so let's take let's write a loader that changes how Node.js resolves the URL. And in this case, the example I will give is something that overrides modules. And I will give an example. For example, let's take this main.js, which imports a module to override. Okay? Simple file. And I will tell you that a module to overwrite does not exist anywhere everywhere. So if I run it, I will obviously get module not found. Makes sense. But the idea is to write a loader which, if it finds an overrides.json file, will know to change a module to override to .moduleoverride.js. And here we have the module override.js, which writes. So if I run Node with a loader, and in a second we'll see the syntax for running with a specific loader, and we'll also see the loader code, then boom, module overridden, and it will work. So first of all, let's talk about the syntax. -- loader. A lot of you will see -- experimental loader because ESM loaders are still in the experimental phase. I think we're really, really close to stabilized ESM loaders, but we're not there yet. So you do -- loader. Note the /. If you don't do /, if you say loader.js, it will search for a package called loader.js, which isn't what we want here. So don't forget the / in this case. Let's look at the loader. This is the loader. That's it. This is beautiful. Really. I love it. It's very, very simple, and we'll go over every line and figure it out. First of all, when we load, we JSON parse the overrides.json, read the file. Notice I use here the async version of fs.read file because top level await, where you can use await in the top level, is supported very, very nicely, only in ESM, not in CJS. As I said, I fart in your general direction. Resolve. When a loader exports a function got resolve, that is the hook for Node.js to call this function when it needs to resolve a specifier. It gives the specifier, we'll talk about the parameters later. And obviously async, because ESM is an async module system. The specifier is a module to override in our case. It's what is given in between the quotes when we import something. Context, we'll see later. And next resolve is, if I don't know what to do with something, I pass it on to next resolve. Simple, chaining. So, what do? If I get a specifier, I check whether it's in the JavaScript object. If specifier is in overrides, I say, okay, I go to next resolve. I don't know how to resolve, but I can give it over to next resolve, but I won't give it the specifier. I will give it the mapping of the specifier to whatever is needed, and I call next resolve. If the specifier isn't in overrides, I just call next resolve with the specifier as usual. And boom, not gonna do live coding because I'm a chicken. But it works. Believe you me, there's a GitHub repo with all the code, by the way. Feel free to check it out. Link at the last slide. Okay, so we saw enhancing the resolution phase. Let's talk about the more important one, the more interesting one, enhancing the loading phase. Loading is when Node.js has resolved the URL, it has a full URL, now it wants to read the file. Sorry. Okay, let's try writing a resolver. I said Node.js doesn't support HTTP URLs. Well, let's write a loader that loads from HTTP. For example, this code import will fail if I run it with unsupported URL scheme when I run it without a loader. So let's run a loader. Let's write a loader. Just like we have the hook resolve, we have the hook load. If Node.js sees the function load in a loader, it will call it to load the file. So what does it get? It gets a URL, which is the URL of the module. Context, we'll see later. And next load, if I don't know how to load it, I'll pass it on to Node.js. So if URL starts with HTTP or HTTPS, then I use the built-in fetch, which I now have in Node, to fetch the URL and get the source. No real error handling here. And I return the source as an object. As you can see, the source code of the module, just return it, and Node knows to do it. I have to say whether it's CJS or ESM. In our case, we'll just say it's ESM, which is module. And if I'm not calling next load, for some reason, I have to pass short circuit true. No idea why. But if I don't, it says, well, you should pass short circuit true, and then I add it and it works. I think it's a defense mechanism or something like that. So, will this work now? Oh, wait, it doesn't. Unsupported ESM URL scheme. Why is that? I hated it. I tried it and it didn't work. Why? Because remember, we have two phases, the resolution and the reading. Node, when the resolution part finds an unsupported scheme like HTTP, it will throw and not even reach the loading phase. Oh, I think this is wrong. But unfortunately, I have to deal with that. And we have to override the resolution too. And this is where the code gets really hairy, really interesting. So please pay attention. Okay, first of all, remember what specifiers are. Module./module.js, write path, those are specifiers. And we have three kinds of specifiers: relative, absolute, and bare. Let's see, relative is // where you start either with dot or dot. And bare specifiers is where it's not an absolute URL, it's just, a name. That's for a package. Absolute URLs you basically don't see. Is something like this or an HTTP URL or whatever. So bare specifiers, we don't know what to do with them. We'll let Node handle them. We need to deal with relative and absolute URLs. So what do we say is, if this is a bare specifier, we'll see this function in a second, we call Node. So how is bare specifier work? If it starts with a dot or a // it's not a bare specifier, it's relative, boom. Otherwise, we try and check if it's an absolute URL by parsing it using new URL. If it fails, then it's a bare specifier, otherwise it's an absolute URL. So we dealt with bare specifiers. Now we have relative and absolute. What do? If it's a relative URL, we need to absolutize it with its parent URL and get the full URL, because that is what the resolve phase does. Look at what we're doing. We're basically duplicating all the code Node.js has just because Node.js is throwing an error like back in that. So how do we do that? How do we absolutize the URL? We just use new URL, give the specifier, give the parent URL, get the href. We've absolutized it. And this is what we're doing here. And if it's an absolute URL, it also works, this code. And this is where we need to tweak if it starts with HTTP, instead of throwing an error like the node resolution error, then we return a URL. We return the URL and not pass it on to Node.js. Otherwise, we pass it on to Node.js and we're good. This is crazy. Now, first of all, wait, our loader works. This is good. HTTP loading for the masses. But this is crazy. We're just duplicating Node.js resolution code. We're taking the code, copying it, and just doing the same, probably with errors, without handling edge cases, etc., just because the resolver throws an error. I hated it. I hated when I wrote the code for this talk. So I changed it. I went to the Node.js loader people. I told them, look, this doesn't make sense. And they said, oh, fine, write a PR. And I wrote a PR, and it was accepted. And in Node 20.3, you do not need to write the resolver, that ugly, ugly code back there, but only from 20.3. There we go. There we go. Let's write another loader, transpiling TypeScript. Obviously, everyone wants their TypeScript code to just run without any need for TS Node or whatever. So you can just load loaders. Now, the previous loader we saw really supported loading from loading sources like HTTP or whatever, FTP or I don't know, a BitTorrent. This loader is more of a transformer. It takes code that was previously loader and transform it into another loader. So it's a different type of loader. For example, we have TypeScript code, the tsmodule.ts, and it should work. Okay, so we run it without, we get unknown file extension, and with, obviously, it works. So we're good. Let's look at the loaders. Look at how simple it is. This is amazingly simple. Really, using ESM loaders is mostly easy. They did a very, very good job of writing the API, I think. It passed through a lot of phases, but I think the end result is really good. Okay, so let's look at the code. We're still using load, by the way. Those are the only two hooks, load and resolve. We're still using load. So if the URL ends with .ts, we don't know how to load it, so we pass it on to Node.js and tell it, next load. We get back the source and the format because that is what the loader resolution phase returns. Now, we just transform the TypeScript like this, const code, get back the code. How do we transform? I just use ESBuild because it has the simplest API. You can use SWC, TSC, whatever. I totally ignore all the really, really big shit about tsconfig and all that TypeScript horrible stuff. But ESBuild is fine. It works for demonstration code, and I return the source code after it is transpiled. That is it. It just works. And transpiling HTTP and transforming HTTP to TypeScript, transforming TypeScript code into JavaScript just works with very, very, very simple code in the loader. But what we really want to do is combine all these things. We want to chain loaders. And there was a time when ESM didn't support, Node didn't support loader chaining, but I think from version 16 or 18, it now supports chaining loaders together. So let's do HTTP and TypeScript, which makes sense. So let's take this file. I'm importing from HTTP a JavaScript file. I'm importing from a TypeScript file. Perfect. I run it. Can we do it? Yes, we can. It'll work. And I'll show another one where we do HTTP, TypeScript, and the override. So for example, instead of the HTTP URLs, I have A and B, and I override it with overrides JSON. So I say A is HTTP and B is whatever. And we'll use the three loaders we built previously to make this example work. And this is the way. You do say -- loader and give the three loaders. These are symbolic names for the loaders we previously built. Obviously, it should be a little bit different. And does it work? Yes, it does. But let's see how, okay? Because we have two phases, the resolution phase and the loading phase, and each one has its own chaining. So let's see how this works. It's a bit hairy. First of all, the resolution phase gets a specifier, like whatever is inside the quotes, and spits out a URL, right? And this is how the chaining works. It goes to the override resolver, HTTP resolver, then Node.js resolver, the default resolver. Notice that it's the opposite way. So if I specify HTTP loader, TS loader, override loader, it goes the other way. Why do I scratch out the TS loader? Because it doesn't have a resolution phase, so we don't care about it here. So let's see. The specifier goes in. goes through the override resolver. The override resolver reads the override JSON and resolves via override JSON and passes it on to which resolve? The next resolve, if you remember. Next resolve in this case is not the default Node.js resolver, it's the HTTP resolver in this case. HTTP, if it's non-HTTP, it passes it on to the node resolver. If it is HTTP, it just returns the URL as is. Okay? And there we go. This is the part of the resolving. Chaining loaders, again, we reverse the order. The load phase takes a URL and spits out code. That's what the loading phase does. So TS load gets the code. TS code doesn't know how to load the file, so it passes it on to HTTP and then to Node. When it gets back the source code, it transpiles it and returns the source code. HTTP loader, if it's a non-HTTP URL, it doesn't know what to do. It passes it on to the HTTP loader, as we saw, and gets it back and passes it on. If it's an HTTP URL, it fetches and returns the source code. And there we go. The chaining just works. Very, very simple. Mostly works. Sometimes if you get the order wrong, it doesn't work. So you have to think about what is happening here to get the order right. Loaders with APIs. This is 8 minutes. Okay, let's see if I can do it. Okay, what happens in the following code? This is a totally different thing. If I do an await import module.js and another await import module.js, and if module.js has a console log, okay, what happens when I run main.js? Do I console log twice or once? Who says twice? Who says once? I love you guys. Thank you. Yes, once. Why? Because the second time I'm awaiting, the cache comes in and the module is already loaded and we're good, as we said. So what is the cache key of a module? The cache key is the final resolved URL. It's not a specifier, obviously. It is the final resolved URL from the resolving phase. Know that. What I want is this. I want await import, clear cache, await import. This is what I want. A lot of people want it. There is no cache clearing in ESM. So how do we do that? This is the requirement. How do we do that? We write a loader for cache clearing. So this is what we want. An import from loader API, await import, clear cache, await import, and we want this to happen. So loader API is the API that needs to communicate with the loader itself. Got it? Here we go. Okay, the idea is this. Every time we call clear cache, we increment a generation counter. It's like a number. And we add this generation to every resolved URL via query parameters. Example, we start with generation 0. We do an await import. We will transform the URL using the resolver and add $gen equals 0. Okay? Obviously, the import isn't there, so Node will load it. Now, we clear the cache. This increments the generation, and when we import it again, we change the resolved URL, add gen equals 1, and Node.js thinks there are different URLs, will reload the module. Don't try this in production, because the other module is still in RAM. Okay, it's not really clearing the cache. It's just using another version of the same module. It's great for testing. It's great for these kinds of things. Do not use it in production. How do we communicate between the two? And because these are separate modules. And the answer, via global. Okay, we'll have an underscore generation. Obviously, we should be using symbols, but this is to make it easier, simpler. So clear cache is easy. Global this dot increment the generation. Easy. And the loader is also easy. I don't care. I just call next resolve to get back the URL. Add the query to the URL. I leave this as an exercise to the implementers, and then return the new URL. And boom, it works. It's that simple. Okay. Okay, a small note, this works, node if else, if the node calling URL. Unfortunately, this doesn't work. If somebody wants a PR, Love that. So I have to add this ugly thing. If URL starts with node colon, then don't add generation. Okay, let's try this in Node 20. Doesn't work. Just doesn't work. Why doesn't it work? Because, as Colin said, loaders, your loaders are now in a separate worker. Loaders were moved to a separate worker, thank you, for lots and lots and lots of good reasons. Unfortunately, this breaks. That is what Colin was talking about when loaders broke. A lot of loaders broke in Node 20. We had to scramble and do something else. And what is that something else? Okay? What is that something else is that we use channels to communicate between the API and the loader itself. Okay, so let's look at clear cache. We increment the generation, and we send the generation to the loader. How do we send the generation to the loader? We use a port. A port is a Node.js mechanism to communicate between workers. And we'll see how we get that port in a second. Just believe me, we'll get that port. So we post a message with a generation. That is how we send the loader the new generation. Now, how do we get the port in the loader? And the way we get to the port in the loader is by another hook called global preload, which just gets the port in the context.port, and listens. And it has generation, we'll see in a second. And this is the weird stuff. It returns code that will run in userland, will run where the API is. So Node gets this code, has a global variable called port, and runs it where the API is running, where your userland code is. So now the API, userland has global this dot underscore cc port. If you totally understand it, that's fine. It took me a while. This is a horrible API, and they're working to fix it, but it works. So in the loader, we listen to the message, get back the data, and get the generation. Perfect. And it works. Slightly, because we need to synchronize, wait for the loader to say, I'm done, I got the generation, please continue, otherwise we'll have a race condition between the two. So we create a shared array buffer. Why? Because we are going to use atomics, which is a feature in JavaScript that enables us to use synchronization and a synchronization mechanism like a lock inside it. We create a shared array buffer which can be moved to the worker, and that buffer is shared between the worker and userland. I know this is like really hairy stuff, and we wait. We wait on the shared array buffer for the loader to run, and the loader, when it gets the message, it notifies using atomics.store and atomics.notify. I'm done. That atomics.wait will exit, and we are good. So it also works in Node 20, and we're good. And I did it. Okay, summary, slowly. Loaders enhance these two phases, the resolution phase and the reading phase. The others are we get that. Loaders can be used to load from different sources, can be used to transform source code, transform resolve URLs differently, whatever you want. A loader has two exported functions, resolve and load. The resolution phase gets the specifier and spits out a URL, and the loader phase gets a URL, spits out the source code. That is what it is. To use loader, you can use -- loader, and you can chain them, which is really nice. And to communicate with the loader, use global variables in versions smaller than 20 and global preload ports in version larger and equal to 20. And the future, from my point of view, sorry, ESM haters, the future is bright. We finally have a formal way to do ESM, to do module loading enhancements. It was very informal up to now. It has withstood the testing of time. There are all still small tweaks waiting to happen, but they're really, really getting smaller and smaller. It is very, very simple to use and can be used in a very large variety of use cases. So, thank you very much.